Lesson 34 is implicit differentiation. So first of all, when you hear differentiation, basically we are taking the derivative. Okay. Notice the first thing listed up here, there's two different forms of equations that we can see when involving x and y. This first one is implicit. So if an equation is expressed implicitly, what that means is that the x's and the y's are mixed together within the equation. What we prefer to see and like to see are the explicit equations. We like to see explicit because it's nice and neat, it's y equals, everything over here is x. So we are used to taking derivatives when an equation is written explicitly. When you're just, here's y, find y prime, and you're taking all derivatives with respect to x. Okay. Today, we're going to learn how to take derivatives when the equation is left implicitly. And sometimes they're left implicitly because you can't really get it to be explicitly written, so where it's y equals. So we're going to be taking the derivatives implicitly, so implicit differentiation. And notice it says it's very similar to differentials. Okay, remember we were doing differentials because we had variables mixed in there. If when you took the derivative of an x term, you had to then tag on a dx. When we took the derivative of a y term, we had to tag on a dy. Same idea here. Okay, so you've seen a little bit of this. We're just going to go into more detail. So example 1 there, xy plus 1 equals 2x minus y. Our job is to find dy dx. Excuse me. Which is what we normally find, right? We normally find dy dx. The thing is, if it's just y equals and everything else is x, you can say, oh, okay, derivative of y with respect to x, derivative of all your x terms, we're good. Here, we're taking the derivatives all the way across. Like I said, you take the derivative of an x term, tag on a dx. Take the derivative of a y term, tag on a dy. So, let's start at the beginning here. Derivative of xy.
xy dxy.
Not exactly. So what is the derivative of x? 1. Okay. What is the derivative of y?
So it's y plus x.
Okay, so what is the derivative of y? 1. Notice, what rule do we have to use here? Remember that product rule that I taught? Okay, x is something we can take the derivative of. Y is something we can take the derivative of. So we have to use the product rule on top of everything else we're doing here. So start with, do you guys remember how the product rule works? Take the derivative of 1, usually the first one, keep the other. So what is the derivative of x? 1. We're going to keep the y, and then we took derivative of which term? The x term, and so we're going to tag on a dx. And then you add, this time we're going to keep the x. What's the derivative of y? 1. And then tag on a dy. So I wrote that as 1x dy. So that was product rule there. It looks a little uglier here, but that's just the way it works out. Derivative of 1. What's the derivative of 1? 0. Write a 0 just there as a placeholder, but you don't have to write anything. Okay. Derivative of 2x. No, derivative. 2. Move your power out front, multiply by your power out front, subtract 1 from the power. So it's 2. Which type of term did we take the derivative of? That was an x, so we're going to tag on a dx. Minus, what's the derivative of y? 1. What am I going to tag on here? No, we took the derivative of a y term, so 1 dy. Now, what is it we're trying to solve here? We're trying to find dy dx. And notice what do we have happening? We have a bunch of dy's and dx's all mixed in. Again, the idea we want to do is we want to get all of our dy's on one side, dx's on the other side, and then we will solve. So, step 1, dy's on one side, dx's on the other side. I would say my preference would be let's get the dy's on the left. So any terms that involve a dy need to be on the left. Any terms that involve a dx need to be on the right. So like on this first one, 1x dy is going to stay on the left, yes, because that's a dy term. You guys okay if I write x dy? What has to happen with the 1y dx here? Subtract it over to the other side. So I'm going to subtract y dx to the other side. Now, on the right, the dx term is good, yes. We're going to keep the dx term, so we're trying to get x's on the right. What about this minus 1 dy? What do I need to do with it? Add it to the other side. So I'm going to add, you can write 1 dy or dy. Probably should say 1 for right now. I'm going to add 1 dy to the other side. So let's write out what we have here. I still have, so my y dx moved. I still have x dy, and what am I adding on? 1 dy. And I'm dropping that 0 out. I never needed that. I just wrote it as a placeholder. On the right, I still have a 2 dx. We know we have to move over. What were we moving over? Minus y dx. And then that minus 1 dy, we already moved to the other side. Are you okay with where those terms landed? After you take a moment to take it all in? Now, what? Yep. Okay, so GCF both sides. On the left, what is the GCF that I just set up for? There's a dy. Now, you can factor the dy out front, or you can factor the dy out back. You will see it done both ways. But when you factor the dy out, what's left in the parentheses? X plus 1. So I tend to write it as x plus 1 then times the dy out back. You can put it out front just the same. On the right, what are we factoring out? A dx. So what remains when I factor out the dx? 2 minus y times your dx. Okay, remember my goal? Can you see that? Yeah. My goal is to have dy dx equals. So, on the left, I already have the dy. What do I need to move over underneath that dy? Dx. So, we're going to do several things here. So, one thing I have to do is I have to divide the dx over. So to move this dx, we divide it on the right. If you divide the dx on the right, you divide it on the left. Now, on the left, I have set up dy dx here, yes? But what needs to move that I can't leave there? The x plus 1. So that means I'm going to divide the left by x plus 1. If I divide the left by x plus 1, divide the right by x plus 1. So, do you see what's happening here? X plus 1's cancel on the left. You have dy dx. On the right, my dx's cancel. And I have 2 minus y over x plus 1. Process is a little bit longer. Okay, it definitely is.
Oh, that is our final answer.
That is our final answer, yep. And it's just, again, these implicit equations, it is hard to get them so they look nice, you know. So that's why we have this other technique here. Okay. No questions on that one? Let's try example 2. Now, there's 3 different ways they ask us to do this. Given y squared minus xy equals sine x that are both x and y functions of time. Find dy dx. So, the first one says to find dy dx. Isn't that what we just did up above? Same process then. So, my equation starts off y squared. What's the derivative of y squared? 2y dy. Because when we're doing implicit differentiation, you have to tag those differentials on each place. So, I'm going to start left over here so I don't run out of room.
Oh, did I do it backwards over there? Over there, when you said the 2x and I said x squared, was I just doing it backwards then?
Yeah, you were doing an antiderivative.
Okay.
We're in derivative world today.
I was trying to figure out where that answer came from.
You did the antiderivative, which we'll review. I think we go back to antiderivatives tomorrow maybe. So, yeah. Okay. So derivative of y squared, 2y dy. Minus derivative of xy. How do we take the derivative of xy? The product rule. So the derivative of x was 1. The y is still there, and we have to tack on a dx. So it's a y dx term. If you want, you can say 1 y dx. I just realized I'm going to drop that 1 off at some point, right? Now, officially, we normally say plus, but what's being done to this term? It's being subtracted. So I'm actually going to continue to subtract this next term. We did the derivative of x. We kept the y. Now we're going to keep the x. What's the derivative of y? 1 dy. So I'm going to tack on a dy. That's all the left side. On the right, what's the derivative of sine of x? Cosine x. What variable did we just take the derivative of? X. So we tag on a dx. Are you getting the idea? Every time you're tagging on a dx, a dy is something. Okay. Same technique as last time. I'm trying to solve dy over dx, so I'm going to keep my dy's on the left and move my dx's to the right, which in this case means I'm moving the y dx over, if you will. So now I still have 2y dy minus x dy. On the right, cosine x dx plus y dx. What's my next step? Yeah. Factor out that dx or dy. So on the left, I'm going to have 2y minus x times dy. On the right, cosine x plus y all times dx. Do you know how to get to the end on this one? I want dy dx to be on the left. I have dy on top already. I need to divide by dx, because I want that dx in the denominator of the left. I only want dy dx on the left, so divide anything else away from the left, which in this case, I'm dividing away 2y minus x. What we do on the left, we do on the right. So, you got it? 2y minus x is cancel. I have dy dx equals cosine x plus y over 2y minus x. Okay. Questions on that one? Okay. B.
Is it just for yes, I don't know.
It is. I mean, essentially, if we were asked to find dx dy, and this was a brand new problem and we hadn't just done A, you would take the same steps on A until you get down to right here. The difference is here that we want to be dx dy. So instead of dividing the dx, I would have to divide the dy over. If you divide both sides by dy and I have dx dy over here, well now instead of dividing by that 2y minus x, I have to divide by cosine x plus y. I wasn't going to work through this one. I was going to go with basically take your dy dx and yes, you can flip it. So I was going to say that dx dy is 2y minus x over cosine x plus y.
That's it.
Yeah.
And then wouldn't C be the same answer as A? Like not even any different?
Is very slightly different.
The only thing that's different is you literally putting dy over dt equals cosine x plus y over dy.
Because it's no longer going to be dy over dx, it's going to be dy over dt, we have to do something with that dx. So that has to move. It just changes where your dx is and how the dt figures in. Okay?
Is it raining or is it there?
That's the air conditioner.
Yes.
I only say it's the air conditioner because it just kicked on right over my head. So it sounds like how it always kicks on.
Dude, I just want to be in my own boy right now with the heat on. It sounds so cozy.
Jackson's ready for nap time is what he's saying, right? Okay. I think at home in bed sounds even cozier
I
than
just
sitting
don't
in
know
a...
why. I feel like my car is so comfortable.
Okay, so C. I was, let's see. Okay, what I was going to do is I was going to take, excuse me. I was trying to debate which step I want to take here. I think I'll just take the first step from earlier, okay, and show you how to work from there. So, in other words, if you went through, if we went through here, we would have still had to start with the same derivative, yes? And
What do you have put dx?
yes, you would, because there's an x in the problem. And that, if there was no x in the problem, it wouldn't be, it would be a lot easier. So, okay, all I did is I copied the first line of A straight over. Nothing fancy there. Now, here's the deal. Okay, so yes, you would still have to take, even though we're trying to find dy dt and there's no mention of x's, we still have x terms. There's still an x variable that we're taking the derivative of. So that still has to be in there. Our goal is to get dy dt, yes? So what I'm going to have you guys do at this point is divide every term by dt. Meaning, so I divide the first term by dt. Divide this term by dt. Divide this term by dt. Divide this term by dt.
The dx is just going to stay there.
In other words, part of my answer is going to now have dx dt in it. Yeah. Okay, so now, my job is to get to solve for dy dt. So this time, I want all my dy dt's on the left. All my dx dt's are going to move to the right. So I'm going to keep 2y dy dt, and I'm going to keep the minus x dy dt. My right already has cosine x dx dt, and what am I moving over to join that? It was a minus y dx dt, so I'm going to add y dx dt. Do you see what we can do on the left? We're going to, not just dy, but d dy dt. Good. So we're going to factor out a dy dt. In my parenthesis then is 2y minus x. On the right, I would say go ahead and factor out the dx dt, which means in parentheses I'm going to have cosine x plus y times dx dt. What do I need to do to get dy dt by itself? We're going to divide this 2y minus x over to the other side, and we can put it under the cosine x plus y. So I'm going to have dy dt equals, I already have cosine x plus y, and I'm going to divide that by 2y minus x, and then the times dx dt can just tack on at the end. Yeah, because dx dt is different than dy dt. Dy dt is the derivative of y with respect to t. Dx dt is the derivative of x with respect to t. So those are two different things. Okay, are we getting the hang of it a little bit? I feel like I'm going slow motion. Am I going too slow? They're just long problems, I guess. I don't know. I feel like I don't want to go too slow, but I feel like if I get going too fast and I lose you, that's bad too. Okay.
Every time I look down to write something down, you've got a whole new line. But that's just me.
Okay. Example 3. If x squared y minus y dx equals cosine x, what is dy dx? So practicing one more time before we then start talking about how this relates to slope. Okay. Okay. How do I do the derivative of x squared y? Product rule. So derivative of x squared, keep the y. Derivative of x squared is 2x and dx, right? We're going to keep the y. So you can write it as 2x dxy, or what I'd like to do is 2xy dx. Do you have that one way or another? Okay, so that was derivative of the x, keep the y, plus, now we're going to keep the x squared. What's the derivative of y? 1, and then dy, because we were taking the derivative of a y term. Okay. Now notice, we are minusing this next term. So we're going to minus the derivative. How do we take the derivative of y e to the x? Y and e to the x are two different things again, so it's a product rule. So subtract derivative of y, 1 dy times the e to the x. So I'm going to say e to the x dy. Because I was subtracting this term, I'm going to subtract the next piece. Now I'm going to keep the y, the derivative of e to the x, still e to the x, times dx, because it was derivative of an x term.
So even though it didn't change at all,
we still took the derivative of an x term. It changed, but yet it didn't change. Okay? Equal. What's the derivative of cosine x? Negative sine x dx, because it's an x term we took the derivative of.
I keep on forgetting already.
Okay. So, what do I want to happen now? What, where?
I said y is on the left and your x is on the right.
Okay. dy is on the left, dx is on the right. Or flip-flop it if you prefer. But dy is on one side, dx is on the other side, right? So let's see. I'm going to keep x squared dy minus ex dy. Are there any other dy terms? No. Equals. On the right, I already have negative sine x dx. I'm going to subtract my other x terms over. So I'm going to subtract over 2xy dx. And I had a minus term, so I'm going to add over y e to the x dx. Does that make sense? I kind of did it all in my head. I didn't show, but it seemed like a lot of extra work to show. All those adding and subtracting movements. Okay. And depending on your talent level, maybe you already factored out. But on the left, I'm going to factor out the dy. So I have x squared minus ex times dy. On the right, we're going to factor out dx. So negative sine x minus 2xy plus y e to the x times dx. Do I need to show to the division, or can you see where you're going at this point? We're going to keep the dy, divide the dx over, yes? What's going on top of my answer? That negative sine x beginning one that's already over there on the right, so negative sine x minus 2xy plus y e to the x divided by, what am I dividing by? X squared minus e to the x. So I was trying to move away from the dy. Okay, example 4 when you're ready. It says find the slope of the line tangent to the graph of x squared plus y squared equals 2 at the point 1, 1. Slope of the tangent line. What is slope of the tangent line? Take the derivative, right? Slope of the tangent line is definition of derivative. So my goal on this problem is to find the derivative. Because it said find the slope, that is code for find the derivative. Now, that means because this is another implicit equation, we can use implicit differentiation again. We're talking y's and x's, right? General rule of thumb I'm looking for is dy dx. You can't see what I wrote, can you? Better? Yeah, this one will be easier. That last few were kind of big, kind of nasty. But this one, we can do it. Okay, derivative of x squared. Derivative of x squared is 2x. Tack on the dx. Plus derivative of y squared, 2y dy. Equals derivative of 2, 0. I told you it's easier than the last one, even though we're changing up what we're doing. We need to solve for dy dx. Luckily, you guys aren't watching the screen and you just wrote what we said. I had written the wrong thing there. Okay, so 2x dx plus 2y dy equals 0. We're trying to solve for dy dx. I'm going to personally keep my dy term on the left. So 2y dy. I'm going to subtract my dx term over. So minus 2x dx And then what do we need to do? Divide. If I'm trying to go for dy dx, divide both sides by dx to get dy dx. If I want to get dy dx by itself, divide by 2y. So I end up with dy dx equals,
2x over 2y.
okay, so notice he didn't say dx's. What happens with dx's? They cancel. What can happen with the 2's there? They can cancel. So what can I express this as? Negative x over y. Okay. We have found the slope of the tangent line. Specifically, what did they ask me to do? The slope of the tangent line at 1, 1. What's that mean I do?
I just plug in the x.
Yeah, 1, 1 is x, y values, yes? We have dy dx equals negative x over y. So, if dy dx is negative x over y, fill in those values, it's negative 1 over 1. And negative 1 over 1 is negative 1. So the slope of the tangent line at the point 1, 1 is negative 1. Okay, notice example 5. Does that equation look familiar? Isn't that the one we just did? Which means, do we already know the derivative? Based on the front side of my notes, the derivative, dy dx is negative x over y. Not magic, I'm just saving myself the work. Is that okay, plan? Okay, so it said, find the points on the graph, x squared plus y squared equals 2, and A says where the tangent is horizontal. No? What do you know when the tangent is horizontal? What is the slope when the tangent is horizontal? What's the slope of a horizontal line? There is one. It's 0. There isn't one, and it's 0 are two different answers. Okay. Okay. So right here on part A is talking the tangent is horizontal. So a horizontal line is that, right? And a horizontal line has a slope of 0. So we want to know what points are going to make that happen. So that means we want to know if the slope is 0, we want to know what? We want to know when the derivative is 0. Because derivative and slope, that's the same thing, yes? So what I want us to think, we know already that dy dx is negative x over y equals 0. So what makes a fraction equal 0? When the numerator is 0. So when will negative x over y equal 0? When x equals 0. So they want to know the points where this is true. Well, it happens whenever x equals 0. So what do you think I do with that 0? Plug it in. Okay, let's plug it in here. So my original equation was x squared plus y squared equals 2. So I'm going to do 0 squared plus y squared equals 2. Well, the 0 squared is just gone, right? So y squared equals 2. If y squared equals 2, what do? Take the square root. And what is the square root of 2? Okay, because we're in that equation setting, we have to remember plus or minus radical 2. So what ordered pairs can you give me?
0, radical 0.
Yeah. We use the value x equals 0, yes? We got two y values, a positive radical 2 and a negative radical 2. So that means I have answers of 0 radical 2 and 0 negative radical 2. Now, let me give you a little bit of a visual so it'll hopefully make sense. I didn't remind you today. Do you guys remember what the graph of x squared plus y squared equals 2 looks like? Yeah, when it's x squared plus y squared, that's equals something, that's a circle. So this is a circle with radius of square root of 2 is what's happening. Think about it. Here's my circle. The tangent is horizontal. Where will tangent lines be horizontal? Right there and right there. And so the points we just found are those 2 points right there. Does that help with the visual of what we just did? Okay, now B. Change this up. B says we want the points when the tangent is vertical. So vertical is straight up and down. What's the slope of a vertical line? No slope, undefined, however you want to think about it. What does a fraction look like when you have that undefined or no slope? There is some type of 0 on the bottom. Okay? Some number divided by 0. So now, if we want points of when this happens, you can kind of look back to the last ones and kind of guess what's going to happen. Because where are my vertical tangent lines going to be? If here's my circle, horizontal tangent lines went, okay, here, my vertical tangent lines are going to be over here. And so you can kind of see where this is going. I'll set it up real quick for you, but dy dx, so my slope of negative x over y, we're wanting it to equal undefined. Undefined is when it's a number over 0. So what are we looking for? We're looking for whenever y equals 0. And so if you do the same process you did last time, or as several of you guys have already figured out the order of pairs, I get it. Okay. But you can set in x squared plus 0 squared equals 2. So x squared equals 2, and then, of course, take the square root. X is plus or minus the square root of 2. Plus or minus the square root of 2 are my x values. 0 is my y value, so square root of 2 comma 0 and negative square root of 2 comma 0. For some reason, I wrote negative square root of negative 2. I don't know. Okay, so when I start talking about horizontal tangent, remember, slope is 0, 0 on top of a fraction. Vertical tangent, slope is undefined. That's when 0 is in the denominator. Okay. Got one more. Again, does your equation look familiar? It does. We're just doing different stuff with it. This says, given that both x and y are functions of time, and x squared plus y squared equals 2. So right there, when you hear that x and y are functions of time, that means we're going to have a dt involved here. Okay? A asks us to find dx dt.
dx over dt plus 2y dy.
Yeah. What did I do? Okay. So if we go back to the beginning, x squared plus y squared equals 2. If you're taking the derivative in terms of whatever it is, so derivative of x squared is 2x dx, plus the derivative of y squared is 2y dy, the derivative of 2 is 0. Now, we're trying to find dx dt. So what do we need to do here? Do you remember on the front page how I did this? I divided every term by dt. And technically, I can even divide that 0 by dt to make it official. From here, it is solving. If I try, what do you guys want to do? Get the dx dt by itself? So if I leave the dx dt term, so I'm going to write it as 2x times dx dt. I'm going to leave that where it is. I'm going to subtract over the dy term, so negative 2y dy dt. To get dx dt by itself, we're going to divide by 2x. So now I have dx dt. What happens when you do negative 2y divided by 2x? Except it's y over x. Okay, so my point is, though, the 2's cancel. I have negative y over x, and then tag on the dy dt. So negative y over x dy dt. Now, B is an easy finish. I go with it looks confusing because it's asking something totally new, but it's actually pretty easy. What are they asking us to find on B? dx dt. Do we have a dx dt equation? Yeah, we have a dx dt equation. They're wanting us to find it at 1, 1 when dy dt equals 7. What are those 1, 1s? xy. So, can I use my equation from previous? dx dt is negative y over x dy dt. Can you plug all that stuff in? Negative y over x. So, that's going to be negative 1 over 1 times dy dt, which is 7. Negative 1 over 1 times 7 all becomes negative 7. Whole bunch more expanding with our derivatives. Okay. That took most of our time, not quite all of it. Your homework is in 34. I don't know. I could probably take a quick peek at 33.